Hey, Algebra 2 students, we are going to talk about common logs in this video. We're going to be able to solve exponential equations using common logarithms. So how this works is, for example, if we have bases that cannot be written as the same exponent or cannot be taken to a power. So like 4, I can't write 4, or I can't take 4 to a power to get 19, or I can't write 19 as a power of 4. So what we can do then is we can take the log of both sides to solve this. So then what happens is we have this exponent right here, and we're going to plug it. If you saw my last video, a power is taken to the outside. We call that plugging. So this is going to be written as x times log of 4 is equal to the log of 19. Now we get x by itself. We're going to divide by the log of 4 on both sides. Divide by the log of 4 here. And so x equals log of 19 divided by the log of 4. You want to get this into a decimal value. If you don't have your calculator with you, you can use Desmos Scientific Calculator, which I'll show you how to do that. If you have a calculator that you're using, make sure you cut or you close off the logs, what you're taking the log of, when you enter that in. So if you just go to desmos.com/scientific, it's right here. And under function, you will see log. And so you can take the log of 19 divided by the log of 4. Log of 4, and I think you can just type that in. I was just, oops. The log of 4, and there you go. You should get 2.123. We're going to round to that last decimal place, which that's a 9, so that's going to go up. So this is going to go up to 40. So your final answer should be x equals 2.1240. Okay, let's try another one. Okay, let's try this one. 3 to the x equals 15. We can't write 15 as a power of 3, so we're going to go ahead and log both sides. Okay, so it's going to be x times the log of 3 equals the log of 15. Divide by the log of 3 on both sides. Sorry, my dog is flapping his ears over here. Okay, so log of 15 divided by log of 3. I'll give you a moment to go ahead and type that into your calculator or to Desmos. Remember, you're closing that off. What I got using Desmos. So you should get 2.4650. Okay, now let's get a little more complicated here. When you have two exponents, I'll show you what will happen here. So same deal, we're going to take the log of both sides, and then we'll plug it, bringing our exponent out in front right here. Make sure you have a lot of room for this one. So we want to get the y's together, just like what we would do with any algebra equation. So what we're going to do here is we are going to go ahead and distribute. So it's going to be a negative 2y log 5 plus log 5. So again, we're getting the y's to one side of the equation. So we're going to go ahead and add the 2y over 2y log 5. So we get y times the log of 4 plus 2y log of 5 equals the log of 5. So now to get y by itself, what we can do here is we can factor out a y. So we have a y here, and it's log 4 plus 2 log 5. I told you had to leave a lot of room here. So now that y is factored out, we can go ahead and divide by this whole thing. And yes, parentheses, if you're using a calculator, is going to be very, very important. Because you want to make sure you're dividing by this whole thing. So we will go ahead and put that into Desmos or in your calculator. Again, making sure that you're closing off your parentheses here. So right here, I'm going to go ahead and type that in, what I have. So log of 5 divided by, in parentheses, we want this whole thing, which I think with Desmos, I don't think you need those parentheses. I'm going to try it. See what happens, because I think it'll all just stay in that denominator, which is what we want. Yay, that's what we wanted. Very good. So it looks like we're going to get 0.3495 because this will round up. So there we go. This will equal, y will equal 0.3495. Okay. Okay, one other quick example is when we have e. So e to the x minus 5 equals 6. So when you're doing this, when you want to solve for the exponent and you have a base of e, first of all, you want to isolate the e first. And that's true with any exponent. You always want to isolate it first. Now, how do we get rid of an e? Well, the inverse of e is the natural log. So x equals the natural log of 11. Then when you go to your calculator, you'll see the natural log, and then you can just type in 11. And here's your answer, 2.3979, because that'll round up. So 2.397. We'll go ahead and write that here. Okay, so when you have a base e, you'll just use the natural log. All right, that's all I have for you. You all have a wonderful day, and we'll see you later.